Yes, I am.
Okay, sir, please, can you share your screen with our audience?
Okay. Can you see the screen?
Yes, sir. Thank you. So you can start now, sir.
Okay. Okay. Assalamu alaikum and good morning, everybody. This is Dr. Rahman Ali, Assistant Professor at Qaid-e-Azam College of Commerce, University of Peshawar. Uh, I did my PhD from Kyunghee University, South Korea in 2016 with specialization in machine learning and artificial intelligence. And my research focus is on how we can automatically select machine learning algorithm for our prediction and classification problem. So the today's talk will also be focused on how we can train our young scholars and researchers that they can take a benefit out of this research and apply the already used technique in this research for their research problems. So if we go and look into the organizational informed decision making process, organization are always trying to come up with the decisions uh, to come up with the informed decision for their businesses, for strategic decision making process or any day-to-day business processes. How these decision making process take place, that is guided by intelligent decision making process. In this intelligent decision making process, we see that first data is acquired, and then machine learning models are developed and trained, they are created, and then the models are evaluated and tested for the real decisions. Here, the problem and the difficulty that the researcher are facing and is very challenging and need to be worked on, and people are working in this area, is that how these model could be created in a way that the result they produce is accurate and optimum. Because in this area, in the model creation area, we have a lot of choices of the machine learning algorithm that can be equally likely be picked and used for generating these decisions. But here, we need to be careful and we need to be worked very keenly looking into the nature of the data and the characteristic or the behavior of the algorithm and pick a particular algorithm with the optimum performance measure. So the focus of this today's talk is how we can intelligently select this a particular machine learning algorithm out of a large number of available algorithm for our own data set and for our own problem. So let's see it from an example. For example, we have a domain problem of predicting diabetes types. So the decision-making process will have to pass through some processing steps, and it will decide whether the diabetes of a particular person is type 1, type 2, or any other kind of diabetes it is. Now, this is not a simple process. This process needs some framework and some machine learning algorithm to predict this diabetes case. This is not only the case of diabetes, it can be used for any kind of business process, healthcare domain, or any other domain as well. So here we need some automatic method for the selection of the algorithm out of the different available choices. Now, taking this into a motivation that nowadays we have different kind of families of the algorithm. We have probabilistic algorithm, rule-based algorithm, meta-learning algorithm, decision tree, and similarly deep learning and meta-learning. Different categories of the algorithms are available, and each category has a number of other algorithms. Each category is composed of a number of algorithms. For example, in probabilistic, there are Naive, Bayesian, and in rule-based, there could be mm, um, there could be part JREP and some other algorithm. And each algorithm can be evaluated by different performance measure as well. And each algorithm could be used in different healthcare, bioinformatics, business, and research area. Now, the issue is that if we have this large number of algorithms available with us, and we are working in healthcare or bioinformatics or business, then which machine learning algorithm we will pick? So this is the real problem, and how people have approached this problem so far. So a different method they have used. But if normally the early stage researcher, they are randomly picking a particular algorithm, and if suppose they have picked an incorrect algorithm for their AI or data science or machine learning problem, that in appropriate machine learning algorithm will definitely result in incorrect decision making, and that incorrect decision making will make the problem on which the researcher is working, that will be useless. And so this is the research problem, and it has been tackled by researcher using different ways. The very first and the very easiest way is to use the heuristic approach. A machine learning practitioner or AI practitioner will use his educated guess. Oh, this is the problem, healthcare problem, and it is too close problem. So I will pick J48 is my algorithm because I know that it has worked well in previous cases. So this is a heuristic guess, educated guess, and a heuristic based approach. But it's difficult to perform this heuristic based approach because of a large number of available algorithm, and a practitioner may have the knowledge of 10 or 20 or 30 machine learning algorithm or maximum 100 algorithm, but there is a very large number of algorithm. Then how it is possible to do a heuristic and educated guess approach for picking a right machine learning algorithm? So people moved from heuristic based approaches to empirical analysis. And in empirical analysis, what they do, they pick the 4 or 5 machine learning or deep learning or any EDA algorithms, and they do perform accuracy, recall, precision, F-score, and different kind of evaluation metric they try to evaluate these algorithm. And if a particular algorithm is good on some of the characteristic, then they pick it. But here, an empirical analysis here, again, the problem is that if I compare 2 or 3 algorithm, one algorithm may be good with accuracy, but the other algorithm may be good with time complexity and the training time complexity, and the third algorithm may be bad in training time complexity. So this is there is a trade-off. So one cannot decide that this algorithm is the good one. So empirical analysis is time consuming, and cross validation technique are used, and computationally it is expensive. So people move to meta learning approaches. Meta learning approaches are the approaches in which we extract the meta characteristic from the data and the meta characteristic from the algorithm, and then we map them together and learn these relationship and the association between these meta characteristic and evaluation metric of the algorithm, and then we learn another model, and then that model help us to automatically select an appropriate algorithm for our problem in hand. So how this work? What is this meta learning approach? As from onward slides in the talk onward from this slide, we will be focusing on this meta learning approach because this is the top one and most frequently used by the researchers. So what is this metadata mean and meta learning approach mean? We have two things. We have data or data sets and we have machine learning algorithms. So two things are there. And we are picking a particular machine learning algorithm for our data sets. So algorithm can be measured by different ways. If we are using the classification algorithm, that can be accuracy, precision, F score, ROC curve, and if it is prediction, then mean absolute error, mean square, and if it is used for recommender system, then again head ratio and F score and normalize discounted cumulative gain and different type of measure are used. So which measure we will have to pick? These are the meta characteristic or performance metric of the algorithm category. And similarly, data that we are using, if we are working in healthcare, so our data will be based on the data coming from the hospital, from the patient EHR, EMR. And if it is business, so it will be come from transaction, sales, and those kind of things. So each and every data has its own characteristic, and those characteristics are called the meta characteristic. And there is a vast categories of meta characteristics, simple statistical information, theoretic, model based. So we are learning these characteristics, and these characteristics are actually the metadata of our data set. We are mapping these two things together. So the idea here is in meta learning approach for automatic selection of the algorithm is that at one hand, we have our data sets, and at the other hand, we have a number of available machine learning algorithm. Now, these these data come with these intrinsic characteristic, which are the hidden and internal characteristic of the data set. And on the other hand, the algorithm comes with their own evaluation metric. And there could be a large number of algorithms that in machine learning and AI and data science that they are working on data wrangling, cleansing, feature selection, algorithm selection. So now, the idea is that how to learn the mapping between these meta characteristic of the data and these evaluation characteristic of the algorithm. And if we could map, accurately map these characteristic and learn this association, then we will be able to come up with a smart choice of the algorithm for our problem in hand. So this is the idea behind the automatic algorithm selection using meta learning approaches. And this approach is in compliance with the RICE model of the algorithm selection. RICE is the pioneer in this area, that how meta learning can work and how this process could be made easier. So at one hand, we have the feature space, and at the other hand, we have the algorithm space. From the algorithm space, algorithm performance measures are calculated, and from the problem space, the problem characteristic, meta characteristic are learned, and these are mapped together to come up with the algorithm selection model. Now, to go and drill down this approach into more detail and component level diagram, this meta learning approach could work in this way, that we have data sets, a large number of available data set that could be extracted from open ML repository or UCI repositories or from other repositories. So these algorithms, these data sets uh, are characterized and meta feature are extracted. And on the other hand, we have a large number of machine learning algorithm and evaluation characteristic metric are extracted from these algorithms. These are mapped to give us a training data set, metadata, which we can say that it could be a metadata. Then this metadata could be learned either by another machine learning algorithm or any other learning method, classification method could be used to learn this relation, this association between the meta characteristic and evaluation metric of the algorithm. And here we have used, in one of our research, we have used case-based reasoning to map these characteristic and algorithm performance and come up with the automatic selection of the algorithm. For example, we have trained this model, meta learning model for the algorithm selection. Then when we come up with our new data set, we input this new data set, meta features are extracted, then case-based reasoning extract the similar cases, and then one similar case is recommended is a solution, and that solution is added back to the case base, which make it an incremental learning approach as well. Now, here we have enlisted a few meta characteristics to let you know that what these meta characteristic data characteristic means. So these mean these are categorized into different categories. General characteristic means that how many attributes are there in the data set, how many classes are there, how many binary attribute are there, nominal, numerical, and from statistical. What is the mean standard deviation? What is the positive percentage, default accuracy, imbalance, incomplete instance count, and from statistical, from other percentage of binary attribute and theoretical information, theoretical feature. So this is a large number of more than 120 meta characteristic could be extracted from data set. And here in one of our study, we have used 29 most influential meta characteristic to build a model. And how this process works, so step by step, these could be explained like this way, that first we input the meta characteristic, take the data sets, and from the data set we extract the meta characteristic. So here is the example. We have used wake up for the we have taken this one data set in Weka format. This is the data set, and we have developed a meta feature extractor. This is the meta feature extractor. Meta feature extractor extract the features from this data set, and these features are added into a meta feature database. So this is the meta feature database. So we do this process for more than 100 and 500 and 800 and whatever number of data sets are available with us. We extract the meta feature using this developed open access meta feature extractor. And then we take the algorithms and we do run each data set and this algorithm using this methodology. We do cross-validation technique. We have used Wake Up for this cross-validation process of running an algorithm over a data sets. And then looking for the significance test, and then determining that which algorithm is a good one. So we have used some multi-metric criteria. So this graph shows it because of the shortage of time, I cannot go inside into the detail, but I will share the slides and you can get it. And if still you have any ambiguity, you can ask me by email, or if we have time at the end of the session, you can ask some question as well. So this is, we characterize the algorithms, and then at the end, at one end, we extracted meta feature, and then at the other hand, we evaluated the algorithm, and we get this training data. And then we have used case-based reasoning, as I told you in one of our study. We have used case-based reasoning, so you would be familiar with the case-based reasoning, that cases are stored, And whenever a new case comes and the already resolved cases are retrieved and similarity score is measured, and then the one with the top similarity score is picked as the solution. So these are those similarity functions. Two kind of local similarity and global similarity function are used, and a best performance algorithm is picked using this approach. And this is the algorithmic representation. I'm not going to the detail of this one. And for this meta learning approach, we have developed an open source tool that is available. Link is shared in the subsequent slides. So you can use it, you can adopt it. We algorithm selection interface. We come over here, we upload our data set, and then here we extract the features from the data set. And once the features are extracted, then here we apply select the particular algorithm and the case-based reasoning. And the case-based reasoning, we have used the approach to select us the top three similar algorithms for a similar data set. So here is the similarity score. You can see here 0.93 and here 0.994, and for the other one. And then we use these cases and we adopt the top one. And we store this again to the database. And here it makes our model more accurate because a new case is added as a successful case to the database. And here are some of the results. These results have been taken from one of our study that we used 100 data sets and 9 decision tree algorithms from the Weka environment. And these are the list of those decision tree machine learning algorithm. And then when we evaluated on 50, these are those 100 data set. These are a few meta characteristic are shown over here, and the rest of meta characteristic are here that we have used in this study. And when we evaluated this model, so when we selected the top one algorithm, the accuracy was 57. When we uh, came to top two algorithm, it was 73%. And when in top three, the accuracy is 94%. So how it make our job easier? We input our data to this intelligent tool, and it extract the meta feature, then apply the model and give us top three machine learning algorithm, that these machine learning algorithm are the best one for this particular problem. And then we pick one out of those three machine learning algorithms. So now how this model, how this approach could be used if you are a researcher in data science, or if you are a machine learning researcher in the area of machine learning, or you are working in the area of AI. So all of these, if it is AI or it is machine learning, or if it is data science, you have to pass through this pipeline. You have to collect the data, then clean it, then you have to do some explorative data analysis, then extracting feature, model development and evaluation. And finally, if you are developing a recommendation system, then you have to build a recommendation module as well to come up with the intelligent decision. So at each phase of this data science or machine learning or AI pipeline, we have I have a number of publication, uh, and some of the publication are in pipeline. In the data wrangling, we have one published, one under review, and in the feature extraction, one paper, research journal paper is published. In the recommendation, 3 are published. And in the explorative, we are yet working. And in the model evaluation, we have published 3 papers, modeling and evaluation. And here are the links for your information. If anyone in the audience is interested in this research area, they can visit these paper and they can see that how this model could be used in different phases of the machine learning or data science life cycle. So this is one paper that complex signal and predictive modeling for outlier detection. And here another one is for nice filter selection using meta learning. And here in feature engineering, we have meta learning methodology for feature subset selection, and in the modeling approach, algorithm selection using edge ML. This is one of our my recent paper published. And this is a conference paper already published using this meta learning approaches. And another one in the recommendation area. And this is the open source tool that I showed you. You can visit and you can download it and you can adopt it from the GitHub library. And in this area, we also, in the recommendation area, we also have a framework, open source framework released that could be downloaded from the GitHub library. So if anyone is using this area and working in machine learning or data science area, they could be equally likely be helped. And the benefit would be to machine learning users and machine learning expert. It will not only be used by naive user or young researcher, but this method and this tool and this technique could also enhance the research capability of the machine learning expert as well. So these are some of the selected paper. Thank you for listening, and it's all from my side. If anyone in the audience is interested to work in this area, they are welcomed. And if you have any ambiguity, any questions, so I'm open for the questions.
Thank you, sir, for this wonderful presentation. And now let me ask audience if they have any question. Sir, there is a question, and the question is that what to do if we have problem space and there are no features at all. So is there any mechanism to generate those features? So that is a question, sir.
Okay, your question, if I could understand it rightly, is that if we have a problem space and there is no meta feature for that problem space, then how we can generate or extract the meta feature? It is not possible. The answer is that it is not possible that if we have a problem space and there would be no feature set, meta feature for that. Meta feature, when we talk about a data set, when we talk about problem set means a data set. If I have the problem of diabetes prediction, so I will have diabetes data, and that will be diabetes data set. And when there will be a database diabetes data set, that data set will have a number of variables, and those variable will be one meta feature, and there will be a number of 100 or 2000 or 10,000 instances. So that is another meta feature. There will be the average value of each characteristic. For example, in the diabetes LPT values or some other, those will be having some average value, percentage value. There will be missing values. So those each when we say that we have a problem, so it is mandatory that there will be a meta feature. And how we will extract those, so I presented you one of the tool I have developed for this problem, and there are also some other tools available that could be equally likely used to extract these features.
Thank you, sir, for the detailed answer. अगर कोई और सवाल है तो okay, sir. Some students are interested and they are requesting that if they can contact you in the future, we have your contact address, email address. So some students are requesting to ask or to work with you in the future.
Sure. My email address is there, and you are always welcome to approach me for any kind of research collaboration or any kind of clarity in what I presented over here.
Thank you, sir, for this wonderful presentation. And I hope that our audience have learned a lot and they have benefit a lot. Thank you, sir.
Thank you so much.
Okay, sir.
Okay. Allah Hafiz.
Allah Hafiz.